In this video, I want to have a look at loan repayments. So loans are usually paid off with regular installments of equal amounts, and compound interest is charged on the balance that's still owing in each time period. So the way we work out problems involving loan repayments is pretty similar to the way we worked out problems that were looking at things like superannuation because of those regular installments. The difference is that the installments are being subtracted from the value rather than added. So let's have a look at our first example, which says a sum of $30,000 is borrowed at 12% per annum compounded monthly, and it's repaid with monthly installments of $500. So part A of our question asks us how much will still be owed after 4 years. So we're going to develop this geometric series to solve this problem. So for part A, we're going to have in there after the first month, we're going to have A1, we'll call it, the amount that's left. So we're going to have our $30,000 and we're going to add the interest to that. So because it's 12% per annum, but we're only doing it per month, then it would be 1%. Now to increase this by 1%, we'd multiply by 1.01. So that's the amount that would be owing, but then we're also going to repay $500. So at the end of the first month, the answer to this is how much we still owe on our loan. Now, if we have a look at our second month, we'll call that A2. And the amount that's left after the second month would be this amount, so A1, multiplied by that 1.01 to add on the interest, and then subtract our $500 repayment. So if we write that out, A1 times this is all of this times 1.01. So that would give us 30,000 times 1.01 squared minus, that should only be 500, not 5,000, minus 500 times 1.01. So that's this section. And then we've got our minus $500 repayment for this month as well. Now let's do a couple more. So a third month. So let's call it A3. So that would be A2 times 1.01 to add on our interest, and then minus our $500 repayment. So if we go through and multiply everything in here by 1.01, that would give us $30,000 times 1.01 cubed minus 500 times 1.01 squared minus 500 times 1.01. And then we've got our minus 500 on the end again. Now let's just do one more just so that we're sure we can see the pattern. So this is our fourth month. So A4 is going to be equal to A3 times 1.01 and minus our 500. So we're doing everything in here times 1.01. So it's going to give us 30,000 times 1.01 to the power of 4 now, minus 500 times 1.01 cubed, minus 500 times 1.01 squared, minus 500 times 1.01. And then we've got our minus 500 from here as well. So by now you should be able to start seeing the pattern. So what we're going to do, we're going to leave this term by itself on its own. We're going to leave it alone. Times 1.01 to the power of 4. But this section, I'm going to pull out that $500 as a common factor. So pull out the 500 and we've got left 1.01 cubed minus 1.01 squared minus 1.01 minus 1. They'd all be pluses now because I pulled out the negative. So now that we've got this, we can see that this is a series. Now, if we wanted the 48th month. Now, the reason we want the 48th month is because our question asks how much will still be owed after 4 years, and 4 years is 48 months. So the 48th month is going to be A48. We'll hold to this pattern. So our fourth month, we had 30,000 times 1.01 to the power of 4. So in ours, we're going to have 30,000 times 1.01 to the power of 48. Then we've got minus 500 outside of, and we're going to have 1.01. Now, when it was the fourth month, we had a power of 3. When it was the third month, we had a power of 2 as our highest power. So our highest power is going to be 47. Plus 1.01 to the power of 46 plus, and that'll go all the way down till we've got 1.01 plus 1. So in this now, we can find the sum of this series. So we have, because of this term here as well, we have 48 terms. Our first term is just 1. So we're looking, as this is our first term, second term is our 48th term at this end. So our R is 1.01. That's what we're multiplying by each time. So we can find the sum of this, which means this whole thing is going to simplify to 30,000 times 1.01 to the power of 48 minus 500 times, and now we're going to use our sum of geometric series formula. So we're going to have 1 outside of 1.01 to the 48 minus 1 over 1.01 minus 1. And we can put all of that in our calculators, and we'll end up with $17,755.48, correct 2 decimal places. So that's telling us that we originally borrowed $30,000, and after 4 years, we still owe $17,755.48. All right, so that's part A. Part B of our question asks how much interest will have been paid over the first 4 years. So what we can do to figure that out, we can go for part B, we're going to figure out how much our loan has reduced by. So our loan was originally $30,000, and we just found out that we're still owing $17,755.48. So that means that we have paid back so far $12,244.52. So that's what our loan has been reduced by so far over those first 4 years. Then we can figure out how much we've repaid in repayments. So every month we've paid $500, and we've done that for 48 months. So 500 times 48, and that'll give us $24,000. So even though we've paid $24,000, our loan's only been reduced by $12,244.52. So that means everything else, the difference between those, is all the interest that we've paid back. So interest is going to be our $24,000 minus our $12,244.52, which will give us $11,755.48. So that is the amount of interest that we've paid over those first 4 years. All right, part C of our question asks us, when will the loan be repaid in full? So when do we have $0 owing? So to do that, we're going to use this sort of structure that we came up with before, this pattern. So instead of finding the 48th term, we're going to write the general term. So for that, we're going to have, this is part C, we're going to have AN would be equal to $30,000 times 1.01. Now up here, it was 1.01 to the power of 48. So for ours, it's going to be 1.01 to the power of n. Then we're going to have minus 500 outside of, and I'm going to write this the other way around. So when we wrote this, I wrote it as 1.01 to the power of 47 plus 1.01 to the power of 46, all the way down to 1. I'm just going to write this the other way around. So I'm going to start at 1 and work my way up, all the way up to n minus 1. So we're going to have 1 plus 1.01 plus all the way up to 1.01 to the n minus 1. So now we can simplify this using that sum of the geometric series again in here. So this is going to become 30,000 times 1.01 to the n minus 500 times 1 outside of 1.01, and there's actually n terms in there, minus 1 over 1.01 minus 1. Now we can simplify this even further. So we can have 30,000 times 1.01 to the n minus 500 times, now this 1 can just cancel out. We don't need it there. It's not even cancelling out. We just don't have to write it down. And the denominator there can simplify just to 0.01. I'm not sure why I put a bracket on there. So that simplifies to 0.01. Now in this next step, I'm going to do 500 divided by 0.01. So that would give us 50,000. And we've got that outside of 1.01 to the n minus 1. Now I'm going to expand this bracket out. So we'll have 30,000 times 1.01 to the n minus 50,000. times 1.01 to the n, and then plus 50,000. Now we can simplify that because these are now like terms. They've both got that multiplied by 1.01 to the n. So we're going to end up with 50,000 plus, no, sorry, minus, because 30,000 minus 50,000 is minus 20,000 times 1.01 to the n. All right, so this is our general term. This is going to tell us, we could sub in any number here and it will tell us how much money we're going to have left after that many months. Now, what our question asks us is how long will it take for the loan to be repaid in full? So if the loan's repaid in full, that means we owe $0. So we want to know what n will give us an answer of 0. So to do that, we're going to have to use logs. So we're going to have, if we move this over this side, so we'd have 20,000 times 1.01 to the n equals 50,000. Then I'm going to divide both sides by 20,000, so we'd have 1.01 to the n equals 2.5. And now if you take logs of both sides, we'd have log of 1.01 to the n equals log of 2.5. Bring that n down the front, and then divide by log of 1.01. So we'd have n equals log of 2.5 over log of 1.01, which would give us 92.086 and so on. And that's in terms of months. So if we convert that to years, it's going to give us 7 point something years. I think it's 7 years and 8 point something months, which actually means, spelling months wrong again, which actually means we're going to end up with 7 years and 9 months to repay that loan in full. So because it was 7 years and 8 point something, 7 years and 8 months exactly is just slightly under, so we'd still have a little bit of money left to pay. So after 7 years and 9 months, we'll be completely paid off. They won't be owing anything anymore. So let's have a look at solving problems involving loan repayments.